Okay, in this video, we're going to be going over the multiplication algorithm, which is, again, just the fancy way of saying, how do I do multiplication out on paper? Okay, we're going to start by looking at an example of a one digit multiplied by a two-digit number, and then we'll just build our way up from there. Okay, so you might see a problem on the non-calculator section of the GED test that would say, find the product of 4 and 12. Okay? Now, product is just the math term for the answer when we multiply two numbers together. Okay? So if we multiply 4 and 12 together, the product is the answer that we're going to get. So let's first take a look at really understanding what's going on when we multiply with 4 by 12, more similar to like how we would do it in our head. And then we'll take a look at the algorithm, how we do it out on paper, and make sure that we understand what's happening in each step. Okay, so we've talked about being able to decompose a number by place value. So this 12, if we were to break it apart or decompose it by place value, we'd break it into a 10, because this 1 is in the tens place, it represents 10, and then 2. And then what we could do from there is find partial products or partial answers, right? We do 4 times 10 gets me 40, and then 4 times 2, which gets me 8. If I combine those values together, 40 plus 8 gives me 48, which is what we get with 4 times 12. Okay, so now let's go ahead and look at what this would look like if we were doing the standard algorithm. Okay, just like in addition and subtraction, we would align them vertically, and we make sure that the place values line up, right? The ones place are lined up. Okay, so from here we would say 4 times 2 gives me 8, and then 4 times 1 gives me 4. Okay, where do we see these partial products that we just did here in our standard algorithm? Where's the 4 times 2? The 4 times 2 is right here. And what about the 4 times 10? I didn't say 4 times 10, right? I said 4 times 1 is 4. But this really represents 10. And in our answer, this isn't a 4, this is a 40, right? So what we really did was 4 times 10 gives me 40. Okay, let's look at another example of a one-digit number multiplied by a two-digit number. So the next one we're going to look at is 6 times 14. So find the product of 6 and 14. Okay, again, let's think about how we could do this in our head if we were comfortable with our times tables. We break this number apart by place value, and we're going to find those two partial products. 6 times 10 is 60, and 6 times 4 is 24. If I add those two partial products together, right, we'll find the product of 6 times 14, which is 84. So we know that our answer is going to be 84, and the way that we got there was by breaking the 14 apart by place value and multiplying each of those values by 6. Okay? When we do the standard algorithm, it's the exact same process. Now, I'm going to show it in a slightly different way than we ultimately do it, just for clarity's sake, okay? But then we'll do it again the most efficient way, the way that we're really going to end up doing it. So here, 6 times 4 gives me 24. Again, for clarity, I'm just going to write 24 here, okay? 24. And then I'm doing 6 times 10, right? It's not 6 times 1, it's 6 times 10, which is 60. Okay, here's my two partial products. When I add them together, I get 84. So this is essentially what we do with the algorithm, but there's a couple shortcuts just to make it faster that we do. So let's look at those. 14 times 6. So here I'm going to say 6 times 4 is 24. But instead of writing 24 out like this, I'm going to put the 4 from the 24 down in the ones place, but the 2 of the 24, the 20 belongs in the tens place. So I put it up here right above the 1. Okay? 6 times 4, 24. Now from there, I'm going to multiply by the 1 in the tens place. Okay? In my head, I just think about it like a 1. 6 times 1 is 6, plus 2 more gets me 8. Okay, so let's take a look at yet another example of a 2-digit number being multiplied by a 1-digit number and how we would solve this using the standard algorithm. So we would start here and we say 5 times 7 gives me 35. Okay? We don't need to write these out. I'm just doing it for clarity. 5 times 7, the 3 from the 35 goes up here in the tens place, and the 5 goes down. Okay? And then I'm doing 5 times 3, but this is really a 30, right? 5 times 30 is 150, but I say 5 times 3 is 15, plus 3 gives me 18, okay, or 180. I took the 30 from here, right? That's the 3, the 30 from here. And when I add it to the 15, right, which is really 150, I get 18. Right? What I really did, 30 plus 150 got me the 180. And then I had already had the 5 down there in the ones place. Okay, I know I did a lot of talking, so let's do it the same problem just one more time through without any of the side business to get the process down. 5 times 7 is 35. 5 times 3 is 15. Plus 3 is 18. Okay, let's go ahead and do a 3-digit number times a 1-digit number. So let's do 276 times 6. I start 6 times 6 gives me 36. 36. Then I do 6 times 7 is 42. Plus 3, 45. 45. And then 6 times 2 is 12. Plus 4 is 16. So my answer, 1,656. Okay, the next thing that we're going to look at is what happens if I'm multiplying a 2-digit number by another 2-digit number. Okay, so here we have 23 times 12, two-digit numbers being multiplied together. I again want to pause here and think about how we could do this problem mentally or without the algorithm to really then understand what's going on when we do it. So we have 12 times 23, 23 times 12, the order doesn't matter, right? Now, the way we have it set up here, right, we're going to break apart each of these numbers by place value, okay? So the 12 gets broken into a 10 and a 2, and the 23 gets broken into a 20 and a 3, okay? Then what I'm going to do, I'm going to take each of these values, we can start with the 2, and I'll multiply it by each place value in the 23, right? So 2 times 20 is 40, and 2 times 3 is 6. So together that's going to give me 46. And then I would do the same thing with the 10. 10 times 20. What would 10 times 20 give me? Well, 1 times 2 is 2. So 10 times 2 is 20. And 10 times 20 is 200. Right? Every time I add a 0 here, I'm adding a 0 in my product. So 1 times 2 is 2, plus these 2 zeros. okay? So I would say 10 times 20 is 200, and then 10 times 3 is 30. Add those together for 230. And then finally, I would need to add these two partial products together to get my final answer of 276. Okay? So now let's take a look at the multiplication algorithm, and we're going to sort of compare our understanding here to what's going on. So we start with the 2. 2 times 3 is 6. Pretty clear, right? Okay, this one checked off. We accounted for it. 2 times 2 is 4. Okay, but what did we really do? 2 times 20, 40. So got this one taken care of too. All right. Then we could move to the 1. We say 1 times 3 is 3. But I intentionally made a mistake here, right? What's the problem? Do I see a 1 times 3 that we did here? No, we did 10 times 3 is 30. My 3 here is in the ones place. This is just a 3. But if I had my 3 here, now that represents a 30, right? And I could go ahead and put a 0 right here, okay? We call this a placeholder 0 because as I go through the process of multiplying, in my head, I just say 1 times 3 is 3. 1 times 2 is 2, right? But we've talked about this idea of place value. This is a 10. It's not a 1, it's a 10. So because we're multiplying by 10, we're going to put this 0 here, right? Put this 0 here, and then I don't have to worry about remembering that it's a 10. I can just treat it like a 1. Okay, from here, 6 plus 0 is 6. 4 plus 3 is 7. And nothing plus 2 is 2. We get our answer of 276. Okay, just like in the previous one, I know I did a lot of talking here to kind of really explain the concept. Let me run through this problem again quickly without all the extra talking, just focusing on the process. 23 times 12. We start here at 2 in the ones place. 2 times 3 is 6. 2 times 2 is 4. I put my placeholder 0 because I'm multiplying now by the tens place. 1 times 3 is 3. 1 times 2 is 2. I now add up my partial products. 6 plus 0 is 6. 4 plus 3 is 7. Nothing plus 2 is 2. 276. Okay, we're going to ramp it up just a little bit here, and we're going to look at a 3-digit number by a 3-digit number. So let's just focus now on the process, okay? So we start here. We're going to take this 8, right, and multiply it by each digit in the 576. That's our first step. 8 times 6 is 48. 8 times 7 is 56. Plus 4 is 60. 8 times 5 is 40. Plus 6, 46. Okay, so I'm done with the 8. Well, basically what I just did here, I did 8 times 576, and that answer is 4,608, right? One of my partial products. I'm going to get rid of these so I don't get confused. You could cross them off, but I don't have a ton of space. And now I'm going to move on to the 4. If you remember from our last example, right, this 4 is in the tens place. It's really a 40. So to account for that, I'm going to put one placeholder 0 before I repeat that exact same process with the 4. Exactly what I did with the 8, I'm going to do with the 4. 4 times 6 is 24. 4 times 7 is 28. Plus 2 is 30. 4 times 5 is 20. Plus 3, 23. Okay, so we've now multiplied the 4 by every digit. We're going to do the same thing with the 2. Okay, but that 2 is really in the hundreds place. If this is in the tens place and we put 1 0, right? If we're multiplying by something in the hundreds place, we have to put 2 zeros before we multiply. Okay, 2 placeholder zeros. Okay, I could cross these off or erase them. And now let's repeat the process with the 2. 2 times 6 is 12. 2 times 7 is 14. Plus 1 is 15. And then finally, 2 times 5 is 10. Plus 1 more gives me 11. Okay? We now took each digit of 248 and multiplied it by 576. That's why we have these 3 partial products. Okay? We need to add them up. $142,848 is our product, right? Really big number. Okay, let's take a look at one more example before we wrap up. 1,500. And you know what? I'll write it a little further down so I don't have to erase my numbers. I can show you how we might just cross them off. 1,579 times 863. Okay. So we start here. 3 times 9, 27. 3 times 7 is 21. Plus 2 is 23. 3 times 5, 15. Plus 2, 17. 3 times 1 is 3. Plus 1, 4. Okay, I cross all these off. And I'm moving on to the 6. What do I need to do before that? Put my placeholder 0. I'll stick with the black theme here. Help us differentiate. So, 6 times 9, 54. 6 times 7, 42. Plus 5, 47. 6 times 5 is 30. Plus 4, 34. 6 times 1 is 6, plus 3 is 9. Okay. Time to cross these off. We're done with the 6. Time to move on to the 8, which is in the hundreds place. So we need to put 2 placeholder zeros, right? Basically, right, this one's in the tens place. I got to put a 0 for every digit, every place that's to the right of it. So when I'm multiplying by the number in the tens place, I have to put 1 0. By the hundreds place, 2 zeros. 8 times 9, 72. 8 times 7 is 56. Plus 7, 63. 63. Okay? 8 times 5 is 40. Plus 6, 46. And then finally, 8 times 1 is 8. Plus 4 is 12. Okay? And we have our partial products, our partial answers. Add them all up. 7 plus 7 is 14, plus 2 is 16. 8, 11, 12. That makes 10, plus 6, 16. And as far as where the commas go, right, I go 3, comma, 3, comma. Okay. 1,362,677, right? Whether we're doing a simpler problem or we're doing this problem, the process is really the same. Just make sure you take it one step at a time. The other thing that I hope you've noticed is how much I'm using the times tables, right? My knowledge of the times tables here. And also my mental addition, right? So that there's a lot of, the more comfortable that you can get, if you've watched my previous videos, the more comfortable you can get with adding numbers in your head, making 10 pairs, the more comfortable we are with our times tables. that the easier that this process is going to be, right? Once we don't have to worry so much about every time I'm 6 times 9, I got to look at the chart and it takes me 30 seconds to find it, right? Once I get past that, then I can actually focus on the process and we can start to realize that the process stays the same, right? And it's manageable for us. So I hope that was helpful. Thank you for watching, and I'll see you in the next video.